Good morning, everybody. Sorry if I have pronunciation issues. So, my name is Mubarak Mohammed. I'm a software developer, and I'll be talking to you about application of data analytics in cybersecurity using TensorFlow with Python. Now, before we start, has anybody heard of TensorFlow before the schedule of this program? Have you heard of TensorFlow? Oh, that's nice. Have you heard of Deep Dreams? What of Deep Mind? Okay, thank you very much. So let's start. About me, I'm a software developer, data analyst. I'm a cybersecurity guy. I code in 5 different languages efficiently. And open source contributor, if you've heard of LibreMesh, LibreRouter, I work with them. And also, I'm working on my first RFC, so you can browse on BMX7. I'm working with Alex from Argentina. And I also do some nasty stuff. You don't need to know where I work, so. What we'll be covering, first, what is analytics? Now, you heard of TensorFlow, we'll be talking about machine learning, and other deep learning. Then how does analytics concern with that? Then we also see what is TensorFlow in itself, how TensorFlow works, and how to TensorFlow. Sorry? Okay. Why take this route for cyber analytics? When working with cybersecurity, why taking the route of TensorFlow? So there are other tools to use, there are different libraries, there are different methods to use, but why TensorFlow? It just came out, got released around November 2015 to the open source market. So a lot of people are applying it in different ways. Diabetics, glaucoma, skin cancer. A lot of work has been done on that, where you can just use your mobile phone to snap your skin, and it will tell you if you are susceptible to skin cancer. Then we will dive through little example, then what is in stock in terms of TensorFlow. Now, I would like to apologize. We won't do too much practical because of the time I was given. It's a very tough aspect, and you bear with me on that. Now, what is analytics in itself? Analytics is just a way of going through different data. You go through data based on your requirement to try to gather results, intelligence from it. Now, when I say intelligence, please don't think of security-wise. It can be business intelligence. It can be just human intelligence. Like, I can decide to say, I'm a data analyst, but working with an aircraft company. Like, I'm a consultant for them. I want to help them to build a flight route that is different from their competitor. Now, this is a very good market that most young programmers can work with. And that's the reason why I choose it with Python. Python is easy to learn, as we will see later. Now, you can look at aircraft company. Let me say, for example, company Pycon has an airline. So you get data from other companies. You get from maybe FAAN, that's Federal Airport Authority of Nigeria. Then you also get from them themselves. You try to build a model out of it using TensorFlow, which is open source. You just learn how to build your model. Then you get out a very good routing system for them. So that you tell them, okay, at so-so time to so-so time of the year, you can fly to so-so part of the country. At so-so time, you can change most of your traffic to so-so part of the country. So what have I done there? I've run analytics to gather out marketing intelligence for them. Now, in terms of cybersecurity, a lot of organizations are coming up now. The first results in terms of TensorFlow and cybersecurity started coming out late 2016. And most of those companies did not actually boast of it until early 2017. So if we can try to take advantage of TensorFlow, it will be very good in Nigeria. And as we will see later, there are a lot of ways you can apply it: marketing, security, people, portfolio, and also risk analysis. So I will dive into that. Now, can you see this diagram clearly? From the top here, I will try to shade it. So here we have requirements. When running your analytics, first, you have to look at requirement. I will be applying based on cybersecurity. Let's say, for example, have you heard of Elasticsearch? Anybody? Elasticsearch? Okay, good. Elasticsearch is a tool used to gather log analysis. Let me bring it basics, right? If you work for Lagos State Secretariat, for example, you want to gather logs for every computer that belongs to Lagos State Secretariat, including some of their router. Elasticsearch is open and you can use it. Now, when you gather those logs, what are you going to do with it? It's very terrible when you connect Elasticsearch to computers, and any click you make, it takes the log. Now, who is going to look through all those logs? Nobody has the time. You don't even have the human resources to handle those logs. So, as a developer, you can just look at the whole thing. Okay, I want to be able to check outgoing logs that are outgoing, like outside Lagos State Secretariat network. Then I want to check threats based on it. So I've just started building a requirement on that. After that, then you now start planning your end goal. What do you plan to achieve at the end? To look at high level of packets, to what extent? Then am I trying to search for APT or some advanced persistent threat or something which is something that is very common in cybersecurity now? Forget the normal hackers that steal your password and everything. The real hackers are government. They are well-paid terrorist groups and other things. In the percentage of hacking, they have less than 3%, I think, but they are the most powerful. They run shadow government. And Africa, we need to wake up and learn to build our tools ourselves. Yesterday, Ivan was talking about the opportunity that is there for our youths to take advantage of. To buy a real cybersecurity and a SIM software is very expensive. It will cost you more than $2 million, including installation. Imagine that is being built. You don't need to take your money outside. You are developing your economy. So, then we also have collection. Then you now start your collection. Still going back to our example of Elasticsearch, it will help you to collect all those logs. Then processing and exploration. Now, having knowledge of maybe data analytics, which involve maybe artificial neural network, fuzzy logic, genetic algorithm, you need to go through a lot of academic process, learn the whole thing and all that. But the internet has made it easy now on that. I can just get TensorFlow, for example, build out a model in it. Now, somebody will be asking, okay, why is he mentioning TensorFlow? Why not scikit-learn or NumPy? I will dive into that as we go along. So, look at processing and exploration. So I can choose TensorFlow, check out a model, then train it to give me another model parameter. Let me put it this way. You have a Toyota, you have Honda. I want to break down model for you now. You have a Toyota, you have Honda. Don't look at Accord or Civic. Now, Toyota, you have Honda, you have Peugeot. If you carry a Peugeot engine and put it in a Toyota engine, let's say they are both 2015 model, the mechanic can adapt everything together and so on. But electronically, they will start having conflicts, right? Now, every system has a model to it. Even if the bore rate of, let's say, the piston is the same size, when they were designed, there are model parameters. No matter what you steal from a company, if you steal their design, the moment you get the model parameter, you are done with them. You can leave the company. Like, those parameters determine how well that engine works. I don't know if that makes sense. All right. Then now you now have analysis production. After you've done your exploration and other things, TensorFlow will produce a model parameter for you. So that model is from a scale of, your model performance is from a scale of 0 to 1. It's very difficult to get 1. I've never seen any result with 1 before. But from 0.7 to 0.9 something, yes, that's perfect. It's very good. So we will see all that, then the simulation. Now, once you get that model, you now integrate it into your code. Very good thing about TensorFlow is that they also adapt to mobile phones and other things. Now, what is TensorFlow? TensorFlow is an open source library written in C, right? And it has API. First, it had API for Python and C++. Most developers, even in Google, they prefer working with that of Python because Python handles data easily. We have loads of library for Python to handle data and other things. Then now the next thing is it was built out of Brain Team under Google, and they've built several things out of it before Google now open sourced it. Example application, it can be used for automation, automatic translation from one language to the other. Where, have you seen this app where when you go to a foreign country, for example, you go to Russia, when you use the app, you snap an image, maybe on a signpost, it will translate it for you automatically after snapping it. So an app like that was built using TensorFlow. So don't take TensorFlow that you have to have this big computer and everything. I will get to that when we get to CPU usage and GPU. So that's one of the applications. I don't want to narrow us to cybersecurity alone. So let's try to look at it in that realm. Then also it's been used by Uber, Snapchat, Google. Yes, Google have it on their own. Then a lot of companies are using it now, including NASA, also using it for space exploration. Next, Google, TensorFlow supports C++, Python, Haskell, but that doesn't mean you can't adapt it to other languages. If you know how to do program bridging, like some people hate learning new language when they want to do something. I don't like it. I find Python very interesting and easy for me to handle. I can just jump into a project and start it up front. Now, then maybe I get to a point that, okay, I need to use something on Fortran. Python can easily adapt to it. I need to use something like MATLAB. Python can easily work with all that. So it's very flexible. That's why the Python API is more popular. Then it's also used with R. Now, on TensorFlow core execution, it works with Android, iOS, CPU, all platforms, including Linux, all Linux distro, Unix distro. You can use it on it. Next. Now, how does TensorFlow works? Tensor is an array, right? If you are any mathematics person here, tensor is an array. So you see the diagram here. I'm just looking at the best way to put it here, and we'll dive into it as we go on. Now, you see the logis area, the ReLU area. For all this diagram, there are references there when I send out the material. Then the updates are different. Now, each equation you use, let's go back to our aircraft company. Like, I want to optimize their flight, right? I will build different model. Each one is an equation that you get from TensorFlow, right? Then you now load in your data. Then you set out a target. When it runs through each of those models, it gives you a best performance. So that best performance you get out will range from 0 to 1, as I said. You now pick the highest value and work on it. Each of these model equation is your tensor. Then how it runs through them is the flow. That's just how they got the name. So now, the nodes represent the mathematical operation, the edges, which are the lines, multi-dimensional data array. So we have that in other languages it works with. This is something on neural network I just displayed here. You can see we have our bunch of data coming in from down here, right? Then it's being reduced as we go along, then reduced till we have a final result. That's how it works. Your final result, we have a model parameter you are going to run through to get all that. This may not sound interesting now as we go along, you get to see it. I just want you to understand. Now, advantages of TensorFlow. It is cross-platform. I don't know, I've never heard of any implementation of it on BlackBerry. I've not heard of it, but I think it's possible because of the way TensorFlow architecture is. But on iOS, Android, it works fine. Then quick turnaround to production. Don't take it as I must be good in mathematics before I run TensorFlow. No, you don't have to be. Another one is efficient CPU and GPU usage, which means that when you are deploying for mobile phone, there are different methods of doing it. This lecture won't allow us to do that. So also for CPUs, and you can decide to run it on their cloud using TensorBoard, which you see. TensorBoard, once you get your parameter, your model performance, you now use that equation to run on your mobile platform or something. So TensorBoard is what most mobile developers leverage on. Then in cybersecurity, TensorFlow in cybersecurity. Anybody heard of logarithm? Logarithm software? Yeah, good. I know ETME must have heard of it, sure. So Logarithm is a company that builds SIEM software, that's a security information and event management software. So they've implemented AI on their system, and also they said it's working fine. By that, I think they've gotten a lot of market on it, which means it's working fine. Then you can use it for intrusion detection system, malware detection and analysis, email analysis, online information trace. Now, let's come to a particular area. Let's say, for example, malware analysis. How should I just use TensorFlow for malware analysis? In life, every child, just like the kids that just came up now, they heard about programming. That's why they are able to talk about programming here. If you don't know about the past, you can't talk about the present, then the future is nowhere. Now, TensorFlow takes advantage of something, history, right? It looks at history. When you are doing deep learning, especially in TensorFlow, you look at history. If I want to do a malware detection now, I look at different malware that are existing. You train it to understand that malware, right? Then DARPA, you've heard of DARPA? DARPA, D-A-R-P-A. Okay, good. DARPA is Defense Advanced Research Projects. DARPA is under the US Army, and they really run good projects. They've done a malware analysis using deep learning, and this really helped them to understand how malware works and evolve. So they now built a system that can easily detect malware, even the ones that are not built yet. So TensorFlow in cybersecurity. When you want to implement TensorFlow in cybersecurity, there are different stages. First, you plan, you collect, you analyze, you produce. This depends on your concentration. So I picked these few ones. First, you have to do scanning, develop indicators. Then under the collection, you build relationship between what you've collected, between what your plans have been. Then under the analysis, you look at the 5 W's H. Now, what are 5 W's? What, where, when? Sorry? Why? Who? Then what is the H? How? So you always bury that in your head when you are doing analysis. So the next one is, then you now produce. Either you give out the trend, then target profile as you have it. Next, when do you use TensorFlow? When static detection is not enough for you, because attacks are becoming dynamic these days and they change always. So you see software that doesn't look legitimate is now illegitimate. For example, you may be using AutoCAD. I can plant something in your AutoCAD that used to extract information from your system. That has been seen in project during the F-35 project for the US. Then also, when you want to make use of high graphics for your intelligence simulation, experience for local development and cluster, when you want to make your local developments very efficient. TensorFlow is advised. A lot of countries are working on it, including Ukraine. So, consideration. When using TensorFlow, you have to consider different things. Your end goal, the data size you have. Not every data size can work with TensorFlow. For example, if you are training, there are a lot of sources where you can get it: fish tank, shadow server. You can get your data to train your TensorFlow program. If you heard of shadow server, right? So you can check it, shadowserver.org. Their data is open, but you have to register. Then data types, not int now or something. You have to handle different data types: numerical, categorical, then text. The most tricky one is categorical data. So you have to consider that a lot, where you have IP ports and other things. So you have to consider that. Then why Python? Not because we are in a Python, but on a neutral ground. You bury it within yourself. Python is very easy to deal with. Very easy to deal with. Now, it's easy to understand, very flexible. I've been coding for years now, more than 10 years, but Python is the best thing that I've worked with. The next one was Lua, but Lua has very low amount of library. No much library in Lua. So that's why Python. Now let's look at the diagram critically. For those of you that are interested in TensorFlow, from here we have our data collected in Hadoop, HDFS. So you have your data set. You want to build something out of it. Then the next thing that you have is your Spark executor. The Spark executor, Apache Spark. You've heard of Apache Spark? Apache Spark wraps around your TensorFlow. All these configurations, I will try to talk to the sponsors so that I can send some other files with this on how to do the configuration. They are very easy step but tedious. So it wraps around the TensorFlow for each model of your TensorFlow. Then at the end, it gives you a result. This method can be very tricky when you are working with big data and your computer is small like mine. So you need high-level system to do all that when you are dealing with big data, because this is a project I worked on. So I chose the diagram online, but it's similar to what I did. I have restriction in discussing some things. So we were working with very large amount of data. In terms of row and element, if you are used to NoSQL, we have documents of more than 50 million documents, and we need to run analysis on them. So we did something similar to this. Then after that, you can see that each model, we have different model in your Spark wrapped around it. Then it goes feedback to get your best model out. Then you choose your best model based on this. So I use this representation for that. Then next thing, model performance. What is a good model? I've discussed that from 0.7 to 1, but you can hardly get 1. Thank you. To also test your performance, there's something called TensorBoard. TensorBoard, you can browse about it, is to check your model performance as usual. Then, for example, this is for character recognition, and you get to see their distribution. You can see some green ones here. They are lost in life, and they are redirected. But if you go through the performance, you try to see, okay, what is my performance level, which for this particular one is very high. So you can use TensorBoard to do that. Once you do your pip install TensorFlow, then the next thing is pip install TensorFlow GPU, you get your TensorBoard, and you can access it easily from your system. Now, areas where you can apply TensorFlow: adaptable IDS, intelligent malware detection, smart packet analyzer connected to your system, dark web mining, and other things. These two guys, you can check about DARPA Deep Web Mining. They worked on it. They don't work for DARPA. They don't work for the security agency in the US or anything. They are just normal guys working on their own, and they use TensorFlow a lot. So DARPA now took their project to work with their project, and they are funding them. The funding was about $2.something million, which is very good, and they are developing something good. So you guys can also work on it. Now, is TensorFlow a silver bullet? No. don't try to take it that, okay, I've heard of TensorFlow, then I must use TensorFlow. When do you use TensorFlow? For example, when you are looking to fit and predict existing algorithm, don't go TensorFlow, use scikit-learn. Now, what's the difference between scikit-learn and TensorFlow? Scikit-learn has already existing models, right? TensorFlow has algorithms that will generate models for you, right? So when you have something already existing, don't go TensorFlow, just go scikit-learn. It's easier and faster. Looking to learn quickly on machine learning, you go for scikit-learn. Then now, looking to build your own algorithm with custom function, you go with TensorFlow. When you are looking to build multiple platforms, you go with TensorFlow. Then to optimize for CPU and GPU, also you go with TensorFlow. So you consider all that. I have all the references of what I use here. Then materials, these are different books you can check on. This is one I like very much by Nick McClure. It's a very good material. So thank you very much. I'm not good with jokes. All right, thank you.
All right, thank you very much. It's a wonderful presentation. My name is Kelvin. I'm a data scientist. My question is, must I be an expert in cybersecurity, like the networking side of things, like cybersecurity, before I'm able to apply TensorFlow in network analysis? One. Then secondly, I've built model a few with the Microsoft Azure. Now my question is, can I adapt TensorFlow on Microsoft Azure platform to build models? Yeah. Then the third one is, you talked about leveraging on CPUs. You quite understand data, large sets of data, you need high CPU performance. What do you suggest in terms of platforms that would give me access to high GPUs and things like that, platforms that can help me to build models, maybe that will be pocket friendly enough for me, for somebody who just want to explore and learn? Thank you.
Thank you.
All right, you're welcome. Let me start ground up. Your first question was on cybersecurity. Must you know cybersecurity before you use TensorFlow? Absolutely no. Now, as a developer, try not to be a one-man army, right? Try not to be a one-man army. When working on, let's say, for example, you have an open source IDS. This is an idea. Anybody ready to work on it? Open source IDS, right? Sitting there on GitHub. You want to implement TensorFlow with it, then you commercialize it. Some, based on the license, they allow you to do that. You sit down with a cybersecurity guy, understand it. Developing software is all about R&D, right? You do some research on your own also to look into it. How does an IDS work? Where does this thing get data? Which database is it working with? When do I define something as a threat? You have to look into that. So if you can do it alone, meaning that you have to study deeply. If not, TensorFlow works like this. You train me how to do nonsense, I do nonsense for you. That's it. It's just like a child. When you don't train the child well, he misbehaves. Same thing with that too. So then it's also good, sit down with a cybersecurity guy, he puts you through, then you do it. You must not know cybersecurity. You can just get somebody, you work together, collaborate, and get it done. Then your second question, Azure platform. Absolutely yes. Now, TensorFlow can work with C#, right? Now, you have to learn language bridging. It's very important. Like there was a time I was building a project on C#, then I needed this library. Then TensorFlow was not out to do a Azure neural network. And I was saying, how will I write this thing in C# now? Start translating the whole thing. All what I learned was that all data comes out of the Python library, right? After doing that, I now bridge it with the C#, just sent the data in. So in terms of Azure, try to extract the data you have from Axor, then bridge it into your Python library or C++ library, as the case may be. You are expected to have some problem in terms of data type and transfer. So you just do your research on that. Then your third question. Mobile phone that won't require too high, maybe cost or memory. Now, depend on what you are building. Let's take example. I want to build a mobile app to identify signposts, for example. Now, some people may think that signposts, let me pick something else. Okay, when I see a leaf, I just snap it, and it will tell me the type of leaf, right? I want to build a mobile app like that, so that people can use it when they are looking for apps. Native, my pronunciation is bad. So, when they are looking for apps, they can just snap, and to tell them the type of leaf. Maybe they are searching in the forest or something. Now, that doesn't require much like RAM or processor speed or something. First thing is that you have to gather the picture of lots of leaves, their names, their biological, what's their name? Just gather all those properties, right, together. Then train your model to handle it. Train your TensorFlow to handle it. It generates a model for you. It's that model that you use inside your mobile app, right? So now, your mobile app has a constant model that is just for you alone. If Mr. B now builds similar app, and your mobile app performs better than that one, based on the score level you have, your app is still better than its own. I don't know if you understand what I'm saying. So now, where you require high capacity, where you require high computation is when I'm generating weather data, maybe every one hour, and I want it to keep predicting the next hour for me. You can't use a mobile phone. You need high-level computers for that one. Thank you. Any other question?
Thank you. Please be informed. You can only ask one question, just one.
Okay. Yeah. You answered part of my question by saying you get a model and then you use the model in the app. So when you get a model, you said it's like an equation or something, right? Oh, do you need to have a tensor engine running on your mobile phone for it to use, or you can use just the model and run it on any language? I don't know if you understand. Do you need to have
Yes, you need to. That's a very good question. You need to have that engine on it. So that the model you extracted is just to get the best fit out of all the samples you have. Yes, you need to. Thank you.
My name is Mike. Sorry, I want to take you back to the slide. There is the part that the float. I don't. Okay. Okay, yes. You said you have a mathematical equation you use here. And though I did not see the equation, but I'm trying to understand what kind of equation do you use and how do you simulate it to this form?
Thank you. When I said mathematical equation, you are not to write the mathematical equation. TensorFlow comes packaged with some algorithm. Now, for example, in neural network, we've heard of neural network, right? Just as our brain neurons works and everything. It has an existing, TensorFlow built an existing algorithm on that. So what you are to do is that build a model out of those algorithms. There are ways to do it from TensorFlow documentation. You will see it. Just have several models that you are going to run your samples through. It's existing already in TensorFlow. You don't build any equation. That's why I'm talking about this in this kind of environment. You don't need to like start building your neural network algorithm. Everything has been done, tested. So you are just to look at the data you have, then run it through different model samples you defined in your code. So then you now get the best fit out of it. Using TensorBoard, you can even get other estimators that you now, okay, this is the one I'm choosing. Then you now use it to run the other things. So each of those samples define those equations I'm saying. So I'm just using it deep inside TensorFlow. Yeah. Thank you.
Okay. All right. So my question is, you mentioned TensorFlow with malware analysis, right? So you know the TensorFlow, when you use it with malware analysis, you are doing dynamic analysis. That's you have to register with the ID signatures, and that's how it detects malwares. So what of maybe like for static analysis, instead of you reviewing the codes? So how will TensorFlow help with static analysis in malwares?
The first question is, why should I even try to run it with static analysis? Why should I run it with static analysis? That should be my first question. Now, let's look at this situation. Coming back to the apps scenario, why should I use TensorFlow to identify a leaf when I already know these 5 leaves? When I already know these 5 leaves existing on the table. So why should I use TensorFlow to do that when other tools are there existing? But when should I use TensorFlow is, when I should use TensorFlow is when like I have different malware. Maybe I have collection of like 1,000 plus malware, right? I train my TensorFlow to identify these things are malware. So at that point, it's identifying a new one. It's just using its own knowledge to do a static analysis of malware for you. I don't know if you get what I mean. You get it? If you need clarity, we can discuss more on that. Yes.